Hi there and welcome. My name is Rebecca Weaver. I'm going to be looking at multiplication properties of exponents today. We need to do some exponential notation explained. So here we have a, which is our base, and m, which is our exponent. We say this as a to the m. A to the m means multiply m factors of a. So however, whatever that number is there in m, that's how many a's you have multiplied together for m factors. So if I had something like 4 raised to the third, that would be 4 times 4 times 4. And you would do 4 times 4, which is 16, times 4 again would be 64. If we were to look at negative 2 raised to the third, that would be negative 2 times negative 2 times negative 2. Negative times negative is a positive, times another negative is a negative, or you can just follow this little handy trick, which is if it's an odd number of negatives, it's negative. If it's an even number of negatives, it's going to be positive. I like that trick. Anyway, 2 times 2 is 4 times 2 is 8, so we would get negative 8 for that answer. If we were looking at 4x y squared, that entire quantity raised to the third, that would mean 3 of those 4xy to the thirds. So xy squared, sorry. So that would be 4xy squared times 4xy squared times 4xy squared. And you can't hardly do all of these at once, so let's just do them 2 at a time. And I'll do 4 times 4 is 16, x times x is x squared, and y squared times y squared is y to the fourth. Now we need to multiply that times my 4xy squared, have one of those left. So 16 times 4 is 64. I have 3 of those x's there and 6 of the y's, so that would be 64 x cubed y to the 6. Now let's look at the product property for exponents. So if I have a raised to the m times a raised to the n, that would be equal to a raised to the m plus n, meaning that I would have ma's and na's, and you could just count them or just add that up. In other words, whenever we multiply with like bases, a nice cool trick, just add the exponents. It's very handy. Now if a is a real number and m and n are counting numbers, that's when this is true. So for an example, if I have 4 squared times 4 cubed, that's the same as 2 4s and 3 4s. In other words, it's 4 raised to the 5th. Hey, look, it's a lot easier just to say 2 plus 3, isn't it? Rather than write all those 4s down. That gets tedious. So we've come up with little cool tricks that we can use. And 4 raised to the 5th is a big number. That's 4 times 4 times 4 times 4 times 4. And believe me, it's 1,024. A raised to the second times a raised to the 8th would be equal to 2a's and then 8a's. And you can count those if you want to, but there's 10 of them, or you could just do 2 plus 8, and that's 10. That's the way I like to play. Let's look at a whole bunch of things now. Let's see, how many total x's do I have? Let's just look at this one thing at a time. I got 1 x there and 2 there. That would be x to the third. Count the y's. I have 2 y squared there and y to the 5th. So there's a total of 7 of those bad boys. So that's y to the 7th. Z's, he didn't get anything done. Just write him down. Cool. Now he's done. So let's look at the power property for exponents. Now if a is a real number and m and n are whole numbers, and we have something like a to the m all raised to the n, hey, that's a power raised to a power. That is pretty powerful. That's a to the m times n. That is, when we raise a power to a power, multiply the exponents. So let's look at this. If I have 4 squared all raised to the third, that means there's 3 of those 4 squared guys. That's 4 squared times 4 squared times 4 squared. So you could add those up and say that there were 6 of them, or you could just say, hey, I know this cool trick that if I have a power raised to power, I just multiply exponents. That's a big old whopping number. That's 4,096. Glad I had a calculator. If I have a raised to the third, all raised to the third, what that means is 3 of those a to the thirds. I could write those out and write down 9 of those a's, but I don't want to. I can just do 3 times 3, say that it's a to the 9th, and I'm done. Let's look at the quantity 2xy squared z cubed, all raised to the third. Yikes! I can write this down 3 times and do them kind of one at a time. That would be 3 2's, or 2 times 2 times 2, which is 8. How many x's do I have? Well, I could look over here and say that's an x to the first, but there's 3 of them, or I could just count them over here and say that there are 3 x's, so that's x to the third. For the y's, you can multiply exponents and say that's y to the 6, or you can just count them over there, 2, 4, 6. Y to the 6, z cubed raised to the third, that's 3 times 3, which is z to the ninth. I like that trick. It makes things easier. So let's look at putting everything together. I'm going to do 2 examples for you here. In our first example, got this crazy mess. Now let's eat this pie one bite at a time. Let's not try to get the whole answer in one big whack. We just can't do it. So I've got negative 10 x squared y to the fourth, all raised to the third. So let's do the negative 10 first. That's negative 10 times negative 10 times negative 10. That's negative 1,000. Now let's do the x. X squared raised to the third. X to the 6. Y to the fourth raised to the third. Power raised to power. Multiply exponents. I get y to the 12th. Got that little chunk done. Whew. Now let's do this next chunk. I have negative 2 x, y, z quantity squared. Let's do the negative 2 first. Negative 2 times negative 2, positive 4. X quantity squared, that's x squared, then y squared, then z squared. All right, now what I have to do is kind of see what I've got. So I'm just going to kind of look at this, and I collected my numbers and my x's so I can see where I've got here. Oops, dropped a 0. Let's fix that. All right, like magic, I have that fixed. And so I have the negative 1,000 times the 4, and then just collected my x together, my y's and my z's. Then I'm going to put them all together, and I'm going to say that this is negative 4,000, x to the, there's a total of 8 x's, so that's x to the 8. There's a total of 14 y's, so I write down y to the 14th and z squared. All right, the next one is everyone's favorite kind of problem, fractions. So once again, let's take this a bite at a time. I see that it's 1/2 y squared raised to the third. So I know what the y is. The y is going to be y to the 6. But I need to do 1/2 times 1/2 times 1/2. And on the 2/3 bit, that's going to be 2/3 times 2/3, and then times the y raised to the second. So this is what I've got. I have broken it apart so that I can work with my numbers and my letters and work with those separately. Now, be very careful on this, because 1/2 times 1/2 times 1/2, that is 1/8. So, got that done. 2/3 times 2/3, when I multiply, just go straight across. That's 4/9. My y's are still where they're at. If I look at this, I say I can go ahead and cancel on the front end, which is my favorite thing to do. So I'm going to cancel this 4 and this 8 and make it a 1 and a 2 there. So I've canceled that. Now I'm going to multiply straight across, and I'm going to get 1/18 y to the 8th. And that's all we have for this section. So if you have any questions, we're starting exponents. Be sure and speak up now. My email is rweaver10@alaska.edu. Have a wonderful day.